Good afternoon, Amma. Hello.
సార్ చెప్పండి.
There are two links working. A
ఆ!
link.
సెకండ్ లింక్ సార్ ఇది. లాస్ట్‌లో
Okay.
పెట్టారు కదా!
Hello. Hello. Is my voice audible, ma? Hello.
యెస్ సార్. ఆడిబుల్ సార్.
Yeah, yeah. I can't see. Right. Where is your friend? Will he come or else shall I start?
నో సార్. హి విల్ కమ్. జస్ట్ ఐ విల్
He'll
మెసేజ్ హిమ్.
come. Yeah, yeah, yeah. Okay, I'll wait. Uh, can you see the screen, ma? Raghunath?
యెస్ సార్. యెస్ సార్.
Yeah,
ఇక్కడ
yeah, yeah, yeah. Okay, ask him to come fast, Nana, because it's already 2:10. We are late by 10 minutes now.
సార్ వెయిటింగ్ మీన్స్ ఐ విల్ జస్ట్ కాల్.
Yeah, okay, okay. What happened, Raghunath?
సార్ అతను రిక్వెస్ట్ పెడుతున్నారు సార్. అంటే యాక్సెప్ట్ మీరు చేస్తారా? మేడం చేస్తారా?
లేదు మేడం నా చేతిలో కంట్రోల్స్ లేవు. హలో
ఓకే
మేడం,
సార్.
ఒకసారి మేడంకి కాల్ చేయండి అన్న.
ఓకే సార్.
Yeah.
Sir, he came, sir.
Shall I start, Nana? Hello, is my voice audible?
Yes, sir. Start, sir.
Yes, sir. Madam, hello, Lakshmi, madam. I think she's okay. The recording is already started. Okay, no problem. So I hope you can see the screen now. So in the last class, we have discussed about instantaneous center different methods to solve absolute velocities and relative velocities. In that criteria, we have discussed about instantaneous center method and relative velocity method. So we are going to discuss further about instantaneous center method, and we have discussed how many in a mechanism how many instantaneous centers, how we can calculate those, and for different types of pairs, okay, where the instantaneous center is going to come, all those things we have studied. And today we are going to discuss about Kennedy's theorem. So I hope, do you know what is Kennedy's theorem? Okay, so I'll just write down the definition. This is very, very important. You may they may ask you for 1 or 2 marks. In Gates also they may ask you for the relative motion. For the relative motion between the links between the links in a mechanism, any three links, their three their three instantaneous centers, ICs, must lie in a straight line. So this is the definition given by the Kennedy. So the meaning is, so suppose in a mechanism there are 4 links, 5 links, 6 links, whatever may be the number of links are there. So here you need to consider 3 links. In out of these 3 links, one link should be the fixed link. The other 2 links must be a mobile links. Okay. So if we consider that these 3 links having some finite relative motion between these things, so the rule is, so the 3 common instantaneous centers must lie on in a straight line. This is the definition given by the Kennedy, and also we'll find out whether this is valid. So we'll take a mechanism while solving the problems. So we'll study whether this statement is correct or wrong. Okay, I hope you have understood. Got it? So three
Yes, sir.
instant centers shared by 3 rigid bodies. Here you may take a links, okay, in a relative motion to one another. So all should lie on a in a straight same straight line. This is what Kennedy's theorem. Next is theorem of angular velocity, or simply it is angular velocity theorem. Angular velocity theorem. So this is also important definition. So basically, consider any instantaneous center. So here I'm just consider any instantaneous center. Instantaneous center. So suppose if you take a 4-bar mechanism, see here I have just drawn a 4-bar mechanism. So here 4 links are there, out of which one link is fixed. So this is 2, 3, 4. So here how many instantaneous will be there? So you know the formula, right? What is instantaneous center formula? How many instantaneous center? How we can find out? If number of links are 4, number of ICs will be n into n minus 1 by 2. So what is n value here? 4. 4 into 4 minus 1 divided by 2. So can you tell me the, hello? So
6,
3,
sir.
6. So total here 6 were there. So we'll find out. So here is I12, I13, I14, I23, and I24. Next is I3. Okay, so total here 6 instantaneous center is there. See here why I am not writing here 2 means. So here we are discussing about a different links. Okay, so 2 links should come into picture. So 3I 1 2 or 2 1 1 and the same. I 2 3 or 3 2 1 and the same. So here the combination, the instantaneous center here is totally is how many? 6. So here if you observe here carefully, now the link 1 with respect to link 2. So because this is a turning pair, so because we have already discussed about instantaneous center for turning pair, sliding pair. I hope you remember the last class. Yes or not, Raghunath?
Yes, sir. Yes,
So
sir.
turning pair ekkada center of instantaneous center will lie at the point of contact between the 2 links. So this is again I23. So this is the point. So that means here I can write A, B, C, D. So A, B, C, D are the centers, and you can say I12 and A one and the same, I23 and B one and the same. Similarly, I34 and C one and the same, and I14 and D points are one and the same. So those we have already defined. Now if you observe here carefully, observe I12 and I14. Now will the position of this particular point is going to change or it is going to be fixed? I'm asking you only.
Fixed, sir.
Fixed, because here the link is fixed. Link number 1 is fixed. So I12 and I14, these are called as fixed I centers. Okay, these are not going to move. So, but if you observe here I23 and I34, now these are not fixed points, B and C points. So if I give some torque to link 2, okay, obviously it starts rotating with respect to link 1. So I23 is going to move along this particular path. Similarly, I34 also is going to rotate about this particular point with respect to D as center. So I34 is not like a permanent. This particular point is going to be fixed. Okay, between 2 and 3 is the turning B point. Uh, the point is fixed, but it is not permanent. It is movable. Okay, but I12 and I14 are permanent. So these comes under fixed eye centers. Out of these fixed eye centers, I12 and I14 are permanent eye centers, and I23 and I34 are mobile eye centers. These are fixed, but these are mobile eye centers. I hope you got it. So whatever the eye centers which are fixed eye centers will mark those eye centers. So how many are there? I12, yes, I12 is defined, and I13, is it defined? I13?
No, sir.
No.
No,
I
sir.
one four is.
I14? Yes, I14 is defined. What about I23? Yes, it is defined. I24 is not defined, and I34 is defined. So we have marked these 4 I centers. Okay. Now, before entering into problems, here itself I want to tell you something. So, in order to find out, okay, in order to find out I13, now where this I13 is going to lie in the space, okay, and where this I24 is going to lie in the space. So we'll do one thing to understand how we are going to get I13 and I24 point. So a small circle I'm just taking. So this is my a small circle. So because here, how many number of links are there? My total 4 number of links are there. So to these 4 number of links, okay, or 4 lines, what is the basic shape I can draw? So I can draw a square shape or rectangular shape. Okay, so I'm just drawing that particular shape inside this particular circle. Suppose if at all here number of links are 6 or 5, okay, or 7. So based on the number of links, you can draw here the particular shape. Suppose if n is equal to 6, you can draw what? Hexagon. Okay, so I have joined these particular points. So say this point is 1, 2, and 3, and 4. So here denotes what? 1, 2, 3, 4 are the number of links here. Okay, so I have joined 1 and 2. Why? Because I12 is already defined. So I12 is completed. Next is I2 and 3. So I2, 3 is also defined. So I have joined 2 and 3. Next 3 and 4. 3 because 3 and 4 is defined. Next 1 and 4. All these were defined. So that's why I have drawn this particular what square shape. And now, which instantaneous center you want to find out? I13, I24. First we'll find out I13, then we'll go to I24. So in order to find I13, what you're going to do is you need to join this first particular point I1 to 2, 1 to 3. Now, to go from 1 to 3, in what path I can go? Okay, because I1 to 3 path is not defined. So in what manner I can go from 1 to 3? Okay, so I can go by 1 to 2 and 2 to 3, yes or no?
Yes, sir.
Yes. So I 1 to 2 and 2 to 3. In order to go from 1 to 3, I go by 1 to 2 and 2 to 3. So what you are going to do is, where is I12? I12 is the point A. Okay. Next, where is the point I23? So I23 is the point B. So what you're going to do is you need to join these points I12 and I23 points. So what you're going to do, you need to use your scale. So please, you have to use stationary ma here. So yes, what I'm going to do, I'll join these 2 points. So I hope you got it. Yes or no?
Yes, sir. Yes, sir.
Yes. Now, so only is this the path, or can I go in different path also? I can go by I14 and 43. Yes or no?
Yes, sir.
Yes. So where is I14? Here is my I14 and here is I34. So I'll join these 2 points. Okay. So similarly, again, you need to use your scale. So you have to join these 2 points. I'm just joining. So now these 2 lines got intersected at this particular point. Can you see this particular point, ma? This is
Yes,
Yes,
sir.
sir.
I1. So this is the I center of I13. This is the point. So now we have defined I13 also. Now, what is the link we need to define? Next, I have to define I24.
2, 4.
Yes. How can I go from 2 to 4? Again, I have 2 parts. I can go by 2, 3, 3, 4. And also I can go by 2, 1, 1, 4. Yes or no? So I'll
Yes,
Yes.
sir.
go
Two
by 2,
parts.
3, 3, 4. Where is 2, 3? Here is 2, 3. And here is 3, 4. So I'll join these 2 points. So again, you need to use your scale. I'm just joining these 2. So you have to join these 2 points. You need to extend it. Then how can I go another path from 2, 1 and 1, 4? Where is 2, 1? 2, 1 and 1, 2 are both are same. This is the point. Now 1, 4, 1, 4, here is the point, the horizontal line. So you need to join AD and extend it. This is the point. So here it got intersected. Now this is the point I24. So I hope you got it. Yes or no?
Yes, sir.
So we have defined these 2 points also. Now you can find out by using angular velocity theorem. Okay, angular velocity of any of the link, that is link number 2, 3, 4, because these 3 are movable links, and you can find out any point linear velocity. Okay, that is velocity of I23, velocity of I34, velocity of I13, and also velocity of I24. Now, how can we find out? Now we'll discuss. So I'm going to discuss now angular velocity theorem. So you can now what is the question? You need to consider any instantaneous center. So you can consider here I23, 34, 13, whatever maybe. So here I'm just considering I24. Okay. So here I'm just naming second link as M link and fourth link is N link. Okay. So M and N both are mobile links, not a fixed link. So here I'm just taking I, M, N. Okay. Now this is the point. So instantaneous center, this is the point. So I can say this particular point I, M, N. So if I consider this particular point, so it can be treated on link M. Yes or no? So what is the link? So if I say I24, so here I am considering I24 as IMN. That means here is the second link. So second link is also called as M link. Okay, and fourth link is also called as N link. So if I say that is IMN, so this is the point. So IMN is the point. So I can say, if I can I treat this particular point is on link number M. M is which link, ma? M is the link 2. Can I say like that? Because IMN, right? Hello?
No, sir.
Yes, sir.
Sir,
Why no? You didn't get it?
is I24 on link 2, sir?
Yes.
How, sir?
So this is this particular point. Now, if you just stand there, ma, what I hope you have understood instantaneous center method concept,
Yes,
instantaneous center concept.
yes,
So
sir.
if I stand this particular point, okay. So now you have this particular point. You just stand on this particular point. Now, if you see it, link number 2 will be in pure rotation. Yes or no?
Yes, sir.
With respect to 2, you can see the fourth link is also in pure rotation. Yes or no? That's what we have studied.
Yes, sir.
Okay, so I can consider this particular point, okay, with respect to link 2 also. Yes or no? And
Yes,
with
sir.
respect
Okay,
to
sir.
link 4 also I can consider. Yes or no?
Yes, sir.
Yeah. So this IM point can be treated on link M if I consider only link M, or it can be treated on link N. Okay, so here, so to find out this particular velocity point IMN or I24, whatever may be, so what I can consider IMN, so I can consider first this particular link, yes or no, angular velocity of omega m into, so what is the distance I have to take now? Velocity is equal to r omega, yes or no?
Yes, sir.
Yes or no? Yes,
Yes,
r
yes, sir.
omega. So in omega place, I have considered this particular link. I'm not considering first fourth link because this is n link. First, I'm considering the m link, which is the second link. So omega of this particular link into what is the radial distance I have to take? Because this is the point. IMN is the point. So your reference point is this. From this particular point to which point I have to take?
To link 2, sir.
Yeah. So here I have to take IMN. So this is the point. The distance from this point to I have to consider 1m. So one, which is the one link? One link is the fixed link. I 1m ఇక్కడ ఉందమ్మా. ఇక్కడ m ప్లేస్ లో ఏంటిది 2 కదా. Have you got it right?
Yes, sir.
Yes. So basically, in order to find out this particular velocity IMN or this particular point, I'm just considering angular velocity of link 2 or link m into the radial distance from this particular point to this point. So this is what instantaneous center method, or else I can find out which is equal to, if I consider this particular link, okay, it can also be treated on link n, right? So if I consider this particular link, so I can write omega n into what is the distance I have to take. Again, the common point is this is the point, right? So I mn into I 1 n or 1m 1n. Have you understood? Say yes or no.
Slightly, sir.
You didn't get it? Okay. In yesterday's
Repeat
class,
it once, sir. Repeat
yeah.
it once.
So I'll go back 1 minute. I'll go back because I'll go back to the last class. What happened? Oh, I think there is a problem with the net. Yeah. Good. So in yesterday's class, in last class, which we have discussed this particular what instantaneous center method. Do you remember, or shall I what recollect?
We remember.
Yes, sir. We remembered.
Yeah. So I hope now you got it. So we consider this particular link AB link. Yes or
Yes,
no?
sir.
At an
Yes, sir.
instant, it has moved to A dash to B dash. What we did, we have drawn a perpendicular line. So this is my first point. What is this point? I1. Yes or no?
Yes,
Yes or
sir.
no?
Yes,
So
sir.
so C is the point, D is the point, E, F, G are the different points on link AB. So if I find out if I want to find out velocity of c, what I have to do? R omega. So omega, which omega I have to take this particular link angular velocity, yes or no? So omega of
Yes,
a,
sir.
b, and what is the distance I have to take? R. So in on the space, okay, so in the space I1 is the instantaneous center. So when I'm standing at this particular point, I point, I can say that AB point or this particular link will be in pure rotation. So this is my reference point. So to find out this particular, so this becomes my reference I. So A point కావాలి నాకు ఇప్పుడు velocity, C point velocity కావాలి. So from C I have to take a distance from C to I1. So that means I1 to C is the distance into omega AB. Then I can find out velocity of C. Did you got? Yesterday we did the same thing. This is nothing but the angular velocity ratio itself.
Yes, sir.
అర్థమైందా అమ్మ? ఇంకా అర్థం కాలేదా అది?
అర్థమైంది సార్.
అర్థమైంది సార్, అర్థమైంది సార్.
Okay, so the same concept I've employed here. That's it. So I'm just opening this one. So it's taking time. Give me a minute. సో ప్రియా ఐల్ జస్ట్ టెల్ యూ. సో ఇక్కడ నాకు ఐఎంఎన్ పాయింట్ లేదా I24 పాయింట్ అనేది తీసుకుందాం. I24 పాయింట్ ఏంటి? నేను ఆ పర్టికులర్ పాయింట్ నేను లింక్ 2 మీద కన్సిడర్ చేయొచ్చు, లింక్ 4 మీద కన్సిడర్ చేయొచ్చు. దట్స్ వాట్ ద మీనింగ్. ఓకే, సో ఇప్పుడు నేను దాని యొక్క వెలాసిటీ కనుక్కోవాలనుకుంటే సో ఏం చేయాలి? నేను ఇప్పుడు వెలాసిటీ ఆఫ్ దట్ పర్టికులర్ పాయింట్ ఈజ్ ఈక్వల్ టు ఆర్ ఇంటూ ఒమేగా. ఆర్ అంటే ఇప్పుడు ఏంటిది? రేడియల్ డిస్టెన్స్ కదా.
ఎస్ సార్.
రేడియల్ డిస్టెన్స్ అంటే ఏంటిది? ఆ పర్టికులర్ పాయింట్ దగ్గర నుంచి నా విత్ రెస్పెక్ట్ టు లింక్ 1, ఎందుకంటే నాకు ఇక్కడ ఫిక్స్డ్ లింక్ అనేది రెఫరెన్స్ లోకి తీసుకోవాల్సిందే నేను. సో I12 అనేది ఏంటిది? దిస్ ఇస్ ద పాయింట్ విచ్ ఇస్ కనెక్టెడ్ ద సెకండ్ లింక్ విత్ రెస్పెక్ట్ టు ద ఫస్ట్ లింక్. సో ఈ పాయింట్ దగ్గర నుంచి నా వెలాసిటీ యొక్క ఏదైతే పాయింట్ కనుక్కోవాలనుకుంటున్నానో ఆ పాయింట్ వరకు నేను తీసుకోవాలన్నమాట. ఓకే, ఇప్పుడు అర్థమైందా?
Yes, sir.
Raghunath, I hope I am not getting answer from your side.
ఎస్ సార్, ఎస్ సార్.
నేను ఓపెన్ చేస్తున్నా. సో there is a problem in getting document open. I don't know. Okay. Because I have already plotted those figures there. Give me a minute, Nana. Sorry for the
ఓకే.
delay. No, what happened to this? Okay, I'll start in the new. So I'll write again. Theorem of angular velocity. So you need to consider any instantaneous center. So simply here I'm writing IC. So I'm just writing IMN. So I can write it can be treated on what? Link M. And also it can be treated on link N. Okay. So
Yes, sir.
now the velocity of I M n is equal to omega of what omega of m into I mn into I 1 m. So if at all here you are considering m length angular velocity, here with respect to link 1, that is the fixed link, you need to consider the point what m link, which is also equal to omega n into I mn. So mn is the common point. Hello?
Yes,
Mn is the
sir.
common point. Yes, into 1.
I1N. N.
Okay, so I can write down like this. So from this, what I'm going to do is I'm going to write down angular velocity ratio of omega m divided by omega n is equal to, how I can write my I m n. This is not into the distance between I m n to I 1 n divided by I m n is the distance from I 1 m. So this is nothing but the angular velocity ratio theorem. That's it. It's simple. Okay. So now from this, can you write here, if you see the ratio of angular velocity is inversely proportional to their distance. Yes or no?
Yes,
Hello?
sir.
Yes,
Yes.
sir.
So because the corresponding distance is inversely proportional. So I'm just writing down in the words the definition. Please note it down. So angular velocity ratio, okay, it is defined as defined as ratio the ratio of two links relative to the third link. See here, the third link is nothing but your fixed link. Okay, so the ratio of two links related to the third link is inversely proportional to the distance of their common eye center. Common eye center. So here, what is the common eye center?
IMNs.
That's it. From their respective centers of rotation. So this point, what is the point? So here if you see I1n and I1m, 1m and 1n are the centers of rotation, yes or no? This is what the link with. So if you see here, this is the point. So this is I14 and I34, and here is 2, 3. Here is 1, 2. So if at all in place of 2 and 4, if I keep m and n, then their respective centers of rotation is what? I12 can also be called as I1m, yes or no? And I14 can also be called as I1.
I1N.
So that is what here the statement. So it is defined as the ratio of two links. Okay, angular velocity ratio of two links. So here I'll write, it's better to write angular velocity ratio. Angular velocity ratio of two links related to the third link is inversely proportional to the distance of their common eye centers from their respective centers of rotation. So you need to take this particular distance. So this is I24 point. This is the point I24 or IMN. So from this point to this point, if you take the distance, so you are going to find out omega m, or else you need to take this particular distance if you consider omega n. I hope you got it. Okay. So that means one can easily say that is IMN, I1m, I1n. Okay. So Now, according to the Kennedy's theorem, that these 3 points, if I join these 3 points, it should form a straight line. That's what Kennedy said. Yes or no? Ante
Yes,
kada?
sir.
For
Yes.
the relative motion between the links in a mechanism, any 3 links, okay? So their 3 ICs must lie in a straight line. So we'll discuss now whether these 3, if I join these 3 points, it forms a straight line or not. Now what is IMN place? In IMN place, what I kept I24, yes or no? ఇక్కడ
Yes, sir.
ఇక్కడ ఏమని రాయాలి? I1
2, 4.
2. Next,
I1.
here I can write I14 or 41 on one and the same. Okay, that means I24, I12, I14 ఈ పాయింట్స్ అన్నిటిని జాయిన్ చేస్తే స్ట్రైట్ లైన్ రావాలి. వస్తుందా అమ్మ ఇక్కడ? I24 ఏంటి? దిస్ ఇస్ ద పాయింట్. I12, now this is the point. I14, this is the point. So if I join these 3 points, now is it forming a straight line?
Yes, sir. Straight
Yes
line.
or no? Very good. And now, so if I consider, now just take I13, where is I13? Here is the point I13. I'm not taking scale because we have already discussed. So I hope it will be clear for you. Yes or no?
Yes, sir. Cleared.
Yes, sir. Yes, sir.
This is I13. So if you consider this particular point, any point, say 3, 4. So this is the 3, 4 point. I can see this particular point 3, 4. It will be on I can say 1, 3 and I14. Yes or no? I can treat this particular point on link 3 and also I can treat this particular point on link 4. Yes or no?
Yes, sir.
Yes. So that means if I join these 3 points, I1, 3, 4, 1, 3 and I14, so it should form a straight line. So where is I34? So this is the point I34. Next I13. So I13 is the point here. Okay. Next, where is I14? I14 is the point here. So if I join these 3 points, so do I am going to get a straight line? Yes or no?
Yes, sir.
That's it. Now you can
Straight
say
line.
that the Kennedy's theorem is accepted and proved. It's correct.
Yes,
Yes
sir.
or no, ma'am?
Accepted.
So you can take I23. I can treat this particular point as on link 2 and also on link 3. So you can see I23. So this is the point I23. Next is I12. Where is I12? So here is I12. Next, where is I13? So here is the point I13. So if I join these lines, so these points, again you are going to form a straight line. So it's simple 4-bar mechanism. When we enter into some 6-link mechanism, then it will be some time taking process, but you need to understand. So these are the points. If you join, you will get a straight line. Now if you observe here carefully, in these combinations, this particular combination and I24 combination, okay, so I24, that is I24, so 1, 2 and 1, 4. So observe these two combination. Now where this common I center is lying. So if you observe here I23, so here if you observe I12 and I13, so the common point is lying in between these 2 points. Yes or no?
Yes, sir.
Yes, sir.
Yes. Now if you observe I24 point, so this common point is lying, is it in between these 2 points or some side like left or right side of these 2 points? So if you observe I12 and I14, where is I14? Here is I14. I12 is here, but I24 is not lying center between these 2 points. It is lying left towards their left. Yes or no? Okay. So now
Yes, sir.
if you observe carefully, now here if you see these things, the signature, that means the sense of rotation will be same sense of rotation with respect to the input link or opposite with respect to the input link. Okay, so you need to remember these 2 points. So I'll just tell you when we need to consider positive and when we need to consider opposite, okay, or negative. Got it? So if, so I'm just writing, if I1M and I1N lie at the same side, of IMN, so the direction is same. That means, so if at all it is positive, negative, negative. That means what is IM here? 2, 4. So with respect to the second link and the fourth link, yes or no? 2, 4 means second and fourth link. Now, if you consider these two links, now what he is telling that common I center is lying at the same side of I1M and I1N. So here 1, 2 and 1, 4. So these are lying on the same side. So these are side. It is not lying in between. So their sense of rotation will be same. That means if second link is rotating in clockwise direction, then the fourth link is also going to rotate in clockwise direction itself. I hope you got it, ma.
Yes, sir.
Vastej and Raghunath. Do you got it?
Yes, sir. Yes,
Yes.
sir.
The second note is if I1M and I1N lie at different side of I1 IMN. Different side means, so with respect to IMN, it is lying on the left side, one is lying on the right side. Or if IMN is in between I1M and I1N, so this is the result. The direction is opposite. That means negative. Suppose if second link is rotating in positive, then the fourth link will rotate in negative direction. Now we'll take this particular link, that is this particular point, that is I23. Okay, now you just tell me I23 point is in between I12 and I13. Yes or no?
Yes, sir.
Yes. So second and third link. Now if the second link is rotating in clockwise direction, then the third link will rotate in
Anti-clockwise.
anti-clockwise direction. That's it. So that means when this particular link, okay, this particular point is moved to this particular point, that means it is rotating in anti-clockwise direction. Then this point will rotate like this. Okay, so I hope you got it. So from this position it has moved to this position. That means it is rotating in anti-clockwise direction. I hope you got it. Yes or no, ma?
Yes, sir. Got it.
Yes. So this is the concept you need to understand. Now we'll solve a small problem. It's a gate problem. For 2 marks, it came in gate 2006, I think. So we'll solve that particular problem. With respect to 4-bar mechanism only, they have asked. So this is the problem 1. This particular category. So you have a 4-bar mechanism. So are you noting down? Yes or no? నోట్ చేసుకుంటున్నారా? ఇప్పుడు విని వదిలేస్తున్నారా?
నోట్ చేస్తున్నాం సార్.
యా ఓకే. నోట్ చేసుకోండి అమ్మా, ఇది ఇంపార్టెంట్. ఓకే. And also I forgot to ask you, you please send your mail ID, ma. Last time also I forgot to send the notes with
Okay,
the
sir.
material
Okay,
you
sir.
people have asked. So at last of the session, please remind me. I'll give you my contact number or mail ID. You can mail or text to that particular number. Got it?
Yes, sir.
So this is link 1, 2, 3 and 4. So this is the angle theta. So link 2 is making an angle theta, and the length of the link 1 is A, and also the length of link 2 is also A. Okay. So when theta is equal to, this is the question, ma. So he is asking that when theta is making 180 degrees, so the angular velocity of the second link is 5 radians per second. Okay. So what is the angular velocity of link 3? That is what he is asking the question. Okay. Now can you solve the question, or will solve combinedly? Hello?
Solve combinedly.
Yeah. So basically, so he gave 4-bar mechanism. So in this 4-bar mechanism, 1 minute. Yeah. So in this 4-bar mechanism, he gave that the length of this particular link 1, okay, is distance A, and link 2 distance is also A. Okay. And terminology is A, B, C, and D. So the question he is asking, now when theta is making an angle 180 degrees, So at that time, the angular velocity of the second link, okay, is 5 radians per second. Now he didn't give any sense of rotation, that is whether it is rotating in clockwise direction or anti-clockwise direction, he didn't mention. Okay, but you can understand theta, here he mentioned what anti-clockwise direction. So omega 3 you need to find out. So 180 degrees అన్నప్పుడు అమ్మ theta, that means AD and AB forms a straight line. Yes or no?
Yes, sir. Yes.
Hello?
Yes, sir. Audible.
Hello? I am just drawing by using a scale. So please listen. So here is the point. So this is the point A and D. So what is the distance here? The distance is, so I'll write capital A and capital D because he gave here small a. So you people may get confused. So A, B, C, and D. So capital N, A and capital D, the distance is A, small a. And now it has rotated, the second link has rotated anti-clockwise and it has reached 180 degrees. So I am just drawing from this particular point to this particular point, and the distance is also same A. So this is the point B, and the distance is also A. So what is the angle it has rotated? It has rotated 180 degrees. And this is the link fixed. Okay, and BC is the link BC, and this is the link CD. Okay, I hope now at from up to this, do you got or not?
Yes, sir. Got. Yes, sir.
Yeah.
Got it.
So as I said, because it's a 4-bar mechanism, how many number of ICs will be there? N is equal to 4. So ICs will be
6.
4 into 4 minus 1 by 2. So total is 6. 6, yes or no? 6 ICs
Yes,
will
sir.
be there. So here number of links are N. So I'm just drawing it. So 1, 2, 3, and 4. Now if you look here, this is the point, this is link 1, and this is 2, and this is link 3 and link 4. So this point, what is the IC center? C is the point, it is the IC center of I34. Now what about this? D point
1,
is
4.
also called as 1, 4. Very good. Here I 2, 3.
2, 3.
Second link and third link, right? And this point is I
Yes.
1,
1, 2.
2. Okay. Now you need to find out what I13, and also you need to find out I24. Yes or no? That's it, right? So
Yes, sir.
I12, I13, I14. Similarly, I23 and I24 and I34. So here we got I34, I12, I14 and I23. Now these are the 4 IC centers which define. So we need to find out I13 and I24. And to find out I13, so I'm just joining this particular point I13. So how I can go from point 1 to 3? I can go by I12 as well as I23. Yes or no?
Yes, sir.
So where is I12? Here is the point I12. Now where is I23? This is the point I23. So what I have to do? I need to join these 2 points. Yes or no? And I
Yes,
need
sir.
to extend it. Clear?
Yes, sir.
Are you getting? Yes.
Yes, sir. Yes, sir. Extend.
Yes, sir.
So I'm just extending these 2 points. Okay, so don't get confused. So I've extended. Now how can I go from I1 point 1 to 3? Again I can go by I14 and again 4 to
4,
3.
3.
Where is 3, 4, 1, 4? This is the point 1, 4. And 3, 4 is the point here. So you need to join these 2 points. So ఈ రెండు జాయిన్ చేసిన తర్వాత where it is going to intersect? So I'm just extending these lines. So you don't do ekkada intersect anma. Where, on which point these two got intersected? Hello?
I 1/4, sir.
Yes. So this is the point at point D itself. So I can say I13. So I13 and I14 are now on a same point. Yes or no? Got it?
Yes, sir.
Now I13 I got. What about I24? How can I go I24? So I can go by fast. I21 and 14, right?
1/4.
Where is 21? So here is 2 1. 1 and 1 2 and 2 4, 2 and 1 both are same, right? So
Yes,
this
sir.
is 1 2. And where is 1 4? Now here is 1 4. Now again you need to join
Extend this.
I12 and I14 point. So you need to extend it. So it's on the horizontal line only. Yes or no?
Yes, sir.
Yes. Now what is the next I can go by? 2 3 and 3 4. Where is 2 3? Now this is the point. Now where is 3 4? This is the point. Now I need to extend these two lines. These 2 points. Sorry, I need to join these 2 points and extend it. Have you got it now?
Yes,
So
sir.
ఈ
Got
2
it, sir.
lines కూడా ఎక్కడ intersect అయింది? At point
B.
B.
At point I.
So I23 and I24 both are same now. Got it?
Yes, sir.
Yes. Now why we find out these 2 points? Sir, why? The question comes into picture. So to find out angular velocity of third length, so I'm applying here what? Which theorem I'm applying? Which
Angular
theorem
velocity.
I'm applying? Yes, that's it. So applying angular velocity theorem. Angular velocity theorem. So what is the point? My I23. So velocity of 0.23 is equal to omega of 2 into I23 into I13 is equal to omega of 3 into what is the common point? Again I23, and which is equal to, sorry, this is I12 ma, and here is 13. Got it or not? Say yes,
Yes,
or
sir.
no?
Yes, sir.
Yes, sir.
Yes, sir.
So here, do I know omega 2? ఇచ్చాడా
Yes,
ఇవ్వలేదు
sir.
omega 2?
5 radians per second.
ఇచ్చాడు సార్.
ఇచ్చాడు. So omega 2 I know. Now the distance I23 and I12. And ఎక్కడి నుంచి ఎక్కడికి? I12 అంటే distance ఎక్కడ? From point A. Yes or no? And from point B. What is the distance of A to B?
Small a.
Small a,
A.
that's it. So can I write? I'm just writing directly. Shall I write down directly?
Yes, sir.
So omega 2 is 5
5A.
radians per second into A
A.
is equal to, what is omega 3? I don't know about omega 3.
Omega
Into
3.
I23, a distance between I23 and I13. What is the distance? Where is I13? So I13 is the point of I14 itself. Okay. Where
Yes,
is
sir.
I23? This is the distance.
2A.
So, pardon?
Distance 2A.
Distance is 2A. Very good. Distance is 2A. So A gets cancelled. So omega 3 is equal to, what is the value?
5/2, sir.
So the value is 2.5
2.5.
radians per second. That's it. You got the magnitude. Now in gate, what they are going to do is option A will be plus 2.5. Okay, option B is minus 2.5. C is 10 radians per second, which is plus, and D is say minus 10 radians per second. So these are the options. Now which option is correct? You got here the magnitude, but you didn't get the what direction. Got it? Whether it is plus or minus. How can I find out this particular point? మీరే చెప్పండి ఎలా కనుక్కోవాలి ఇప్పుడు నేను ప్లస్ మైనస్? How I can find out? How I can find out? See, what are the note 2 points? That's why I said please make a note. What is the first point? If I1m, I1n lie at the same side of IMN, the direction is same. Okay. And if I1m, I1n lie at different side of IMN, then the direction is opposite. So which point I have to consider here? What is the common point I need to consider? Ma, you need to answer. Hello?
ఎస్ సార్
Are you
ఎస్ సార్
there?
సార్ ఒకసారి మళ్ళీ రిపీట్ చేయరా సార్ ఒకసారి?
జూమ్
ఇక్కడ పాయింట్స్ మనం డిస్కస్ చేస్తున్నప్పుడు ఇందాక వాట్ ఆర్ ద 2 పాయింట్స్ ఐ సెడ్ I1M ఇక్కడ MN 1 అనేది ఫిక్స్డ్ లింక్ నానా. సో 1 is fixed link. So if I take a reference as first 1 అనేది fixed by default. M and N both are movable links. Okay. సో ఇప్పుడు నాకు ఇక్కడ లైక్ N రొటేషన్ M రొటేషన్ ఐ నీడ్ టు ఫైండ్ అవుట్. ఓకే, సో ఇక్కడ నాకు ఇన్పుట్ M రొటేషన్ ఏంటిది క్లాక్ వైజ్ ఇచ్చాడు అనుకుందాం. అర్థమవుతుందా నేను చెప్తున్నది?
ఎస్ సార్ ఎస్ సార్.
ఇప్పుడు M అనేది క్లాక్ వైజ్ గా రొటేట్ అవుతుంది అని చెప్తున్నాడు. సో ఇప్పుడు N ఎలా రొటేట్ అవుతుంది? నెగిటివ్ గా అంటే యాంటీ క్లాక్ వైజ్ రొటేట్ అవుతుందా, క్లాక్ వైజ్ రొటేట్ అవుతుందా, ఎలా కనుక్కోవాలి? ఇన్స్టంటేనియస్ సెంటర్ మెథడ్ యూస్ చేసుకొని. సో ఆ 2 పాయింట్స్ ఏంటంటే ఇఫ్ I1M అంటే ఈ పాయింట్ విత్ రెస్పెక్ట్ టు ద ఫిక్స్డ్ లింక్ సెంటర్ ఆఫ్ రొటేషన్ ఆఫ్ M లింక్ అండ్ సెంటర్ ఆఫ్ రొటేషన్ ఆఫ్ N లింక్, ఈ 2 పాయింట్స్ కూడా ఒకే సైడ్ అంటే సేమ్ సైడ్ అంటే ఈ ఆ లింక్ పైన IMN లెఫ్ట్ ఉంటే ఈ I1M I1N 2 కూడా దీని రైట్ సైడ్ లేదా ఈ 2 పాయింట్స్ కూడా దీని యొక్క లెఫ్ట్ సైడ్ ఒకవేళ ఉన్నట్టయితే ఈ డైరెక్షన్ అనేది సేమ్. అంటే నా M లింక్ సపోజ్ క్లాక్ వైజ్ రొటేట్ అవుతుంది అంటే N లింక్ కూడా క్లాక్ వైజ్ రొటేట్ అవుతుంది అని అర్థం అని చెప్తున్నాడు అనమాట. ఈ పాయింట్ అర్థమైందా నాన్న? Suppose this is a straight line. So here is my link IMN. So my point I1M is here and similarly I1N like this. So ఇప్పుడు IM కి 2 పక్కన ఉన్నాయి. ఓకే, లేదా ఇలా కానీ లేదా ఇప్పుడు IMN ఇక్కడ ఉంది. సో I1N ఇక్కడ I1M ఇక్కడ ఆర్ ఎల్స్ వైస్ వర్సా I1M ఇక్కడ I1N ఇక్కడ. సో ఈ 2 కూడా లెఫ్ట్ సైడే ఉన్నాయి దీనికి. ఎస్ ఆర్ నో? ఒకవేళ ఇలా ఉన్నట్టయితే నా డైరెక్షన్ వచ్చి పాజిటివ్ అని చెప్తున్నాడు వాడు. అంటే M లింక్ N లింక్ డైరెక్షన్స్ ఏవైతే ఉన్నాయో 2 సేమ్ గా తిరుగుతున్నాయి అని చెప్తున్నాడు. గాట్ ఇట్ ఆర్ నాట్? సపోజ్ సెకండ్ కేసులో ఏంటంటే IMN మధ్యలో ఉంది. సో I1M హియర్ అండ్ I1N హియర్ ఆర్ వైస్ వర్సా. అంటే ఇక్కడ I1M ఉండొచ్చు ఆర్ ఇక్కడ I1M ఉండొచ్చు ఆర్ ఇక్కడ I1N ఉండొచ్చు. బట్ నా కామన్ ఐ సెంటర్ ఏదైతే ఉంది ఈ 2 పాయింట్స్ మధ్యలో ఒకవేళ ఉన్నట్టయితే MN లింక్స్ ఈ 2 లింక్స్ యొక్క డైరెక్షన్ అనేది డిఫరెంట్ డైరెక్షన్ లో రొటేట్ అవుతున్నట్టు. అంటే M లింక్ క్లాక్ వైజ్ రొటేట్ అవుతాయి, N లింక్ వచ్చేసి యాంటీ క్లాక్ వైజ్ లో రొటేట్ అవుతుంది. అర్థమైందా? సో దిస్ ఈస్ ద కండిషన్. గాట్ ఇట్ ఆర్ నాట్?
ఎస్ సార్
ఎస్. సో ఇప్పుడు నాకు ఇక్కడ MN ప్లేస్ లో ఏంటిది 2, 3 పాయింటే కదా. ఎస్ ఓ నో? సో వాడు ఏమిచ్చాడు? లింక్ 2 యాంగులర్ వెలాసిటీ ఇచ్చాడు, లింక్ 3 యాంగులర్ వెలాసిటీ కనుక్కోమన్నాడు. సో ఈ 2 కామన్ ఏంటిది? MN. సో M ప్లేస్ లో ఏముంది? ఇక్కడ 2 ఉంది, N ప్లేస్ లో వచ్చేసి నాకు 3 ఉంది. సో I23 is my common point here. సో అక్కడ నేను యాంగులర్ వెలాసిటీ థీరం అప్లై చేశాను. సో ఐ కెన్ సే దిస్ పర్టికులర్ పాయింట్ మే బి ఆన్ లింక్ 2 ఆర్ మే బి ఆన్ పాయింట్ లింక్ 3. సో ఐ హావ్ అప్లైడ్ యాంగులర్ వెలాసిటీ థీరం. సో దిస్ ఈస్ ద ఫార్ములా ఆఫ్ యాంగులర్ వెలాసిటీ థీరం. సో ఇక్కడ నాకు ఏంటిది? డిస్టెన్సెస్ అన్ని కనుక్కున్నాం, నాకు మ్యాగ్నిట్యూడ్ వచ్చేసింది. నాకు ఇప్పుడు ఏంటి? డైరెక్షన్ కావాలి. సో హౌ కెన్ వి ఫైండ్ అవుట్ ద డైరెక్షన్? ఓకే, సో దాట్ మీన్స్ ఇప్పుడు నాకు I23 పాయింట్ ఏదైతే ఉందో అంటే విత్ రెస్పెక్ట్ టు I12 I13 మనం చూసుకోవాలన్నమాట ఫిగర్ లో. సో దిస్ ఈస్ ద ఫిగర్. ఐఎమ్ గోయింగ్ బ్యాక్ టు ద ఫిగర్. సో I23 వేర్ ఇస్ ద పాయింట్? I23. సో I23 హియర్ ఇస్ ద పాయింట్. ఎస్ ఆర్ నో?
ఎస్ సార్.
సో ఇప్పుడు నాకు ఏం కావాలి? I12 I13. సో I12 I13 2 ఏ డైరెక్షన్ లో ఉన్నాయి? 2 సేమ్ సైడ్ ఉన్నాయా, డిఫరెంట్ సైడ్ ఉన్నాయా?
సేమ్ సైడ్
ఉన్నాయి. సో వాట్ ఎవర్ మే బి ద డైరెక్షన్. ఓకే, సో ఇది కూడా అదే డైరెక్షన్ లో రొటేట్ అవుతున్నట్టు అర్థం. సపోజ్ వాడు ఇవ్వలేదు కాబట్టి సో వీఆర్ అజ్యూమింగ్ దట్ ఇట్ ఈస్ రొటేటింగ్ ఇన్ పాజిటివ్ డైరెక్షన్. సో హియర్ ఐఎమ్ జస్ట్ కీపింగ్ ఇట్ పాజిటివ్. అర్థమైందా? అర్థం కాలేదా?
ఎస్ సార్, అర్థమైంది సార్.
ఎస్. సో omega3 is equal to plus 2.5 radians per second. Got it? Is it clear? Shall we go to the next problem, which is very, very important problem?
Yes.
And this is the question came for 20 marks in engineering services. I hope you know what is engineering services exam.
Yes sir, IAS.
UPSC conduct చేస్తుంది ఈ పర్టికులర్ ఎగ్జామ్. ఇందుట్లో ఈ పర్టికులర్ క్వశ్చన్ 20 మార్క్స్ వచ్చింది, అండ్ దిస్ పర్టికులర్ క్వశ్చన్ will be there, is there in your Ratan textbook as well as in Kurmi also. Okay, so I have to go back to the slide, ma. That's I'm not getting, because I've already constructed a figure here. Otherwise, I have to go here. We'll see now. Otherwise, we'll go back to this particular. Okay. So, is there any doubt up till now? Raghunath and Vasudev?
No doubts, no doubt.
No doubt. I think the strength is constant. ఓన్లీ మీ ఇద్దరికేనా గేట్ చెప్పాల్సింది, లేదంటే ఉన్నారా వేరే వాళ్ళు?
ఉన్నారు సార్, కానీ ఎవరు రావట్లేదు సార్. మామూలుగా విడిగా ఫోన్ చేసి చెప్పాను సార్ వాళ్ళకి. అయితే మేము స్టార్టింగ్ నుంచి రాలేదు కదా, ఇప్పుడు సడన్ గా వస్తే ఏం అర్థం కాదు, మేము రావాలే.
Because they are wasting. See, each and every topic is completely different in com, right? So com లో మీకు పర్లేదు అర్థం అవుతుంది.
Yes sir.
This is the figure. So try to call them back, because if strength is more, na, so these people get advantage. I don't know why they are neglecting. I'm just copying this figure.
Maybe they are planning more than gates.
Means
some other.
Okay. Okay, well and good. If they get okay. Yeah. Hope you can see the figure. This is the question I'm speaking. Kanpistunda?
Yes sir.
This is the size. Somewhat. Because in other platform I have constructed this particular figure, because it will again time taking process. That's why I have constructed. Okay, I'll lock it. Yeah. Okay, so this is the problem. They've asked for 20 marks. Okay, so how many links are there? See, I have drawn with different colors also for identification purpose, but in GATE engineering services there won't be any different colors. Okay, so you need to understand. Okay, so the question is asked in this manner. For construction, they have given the data. So OA is equal to 200 mm. So how you are going to solve this particular problem, I will tell you. So OA is 200 and AB is equal to 1.5 meters. So you can use your protractor set squares also. Okay, so to construct this, OE is equal to 1.35 meters. So basically, Raghunath, I think you only asked in the last class. Apart from gate, also please explain. Yes or no?
Yes sir. Vasudev asked.
Vasutej asked. Okay.
Yes.
So that's why I'm just explaining this particular problem. Okay.
Yes, sir. Okay. Okay.
Okay. So BC is equal to 600 mm and CD is equal to 500 mm. So if OA rotates 120 rpm in clockwise direction, find velocity of B, velocity of C, velocity of D. So you need to find out these three velocities. Similarly, you need to find out the angular velocity of AB and BC and CD. So these are the angular velocities you need to find out. Okay. So OA, and this particular point is B, this particular point is C, and this is Z, and this is D. And here your slider is okay. So now the question comes, sir, how you started constructing this particular figure. So here he gave that O point and E point is on the same line of action. So you can say here on same axis. Okay. So what I did is I took a scale. So to draw this is called configuration diagram. This is configuration diagram. So how to construct this particular configuration diagram? So this is the rough sketch. So first what you need to do is you need to take a scale. Okay, take scale is equal to 100 mm is equal to say 1 centimeter, or you can convert like 200 mm is equal to 1 centimeter. You can construct like that. Okay, so OA is equal to how much they gave? 200 mm. 200 mm. And here the angle, if at all angle is not given, then it will be a difficult for you. So in the question itself, they have given 30 degrees. So the angle is 30 degrees. So you need to mark 30 degrees, and what is the distance? OA is equal to 200 mm, and the scale how much I took? I took 100 mm is equal to 1 centimeter. So how many centimeters here I have to draw? 200 mm, 2 centimeters. So OA is equal to 2 centimeters. Use your compass, O as center, cut an arc. Okay, so earlier itself with respect to 30 degrees you have drawn a line. So 200 mm. So cut an arc and mark the point A. Ardhamaindi kada nana?
Yes, sir. Advain.
Yes. Next, the point is AB is equal to 1.5 meters, which is equal to 1500 mm. Okay, so 1500 mm, but you don't know at where it is going to lie. So take your compass, and how many centimeters here I have to take? 15 centimeters. Yes or no?
Yes, sir. 15.
Yes, 15 centimeters. So use your compass, and from A, you just draw a large circle. So this is the arc. Draw a large arc with 15 centimeters. Okay, but you need to plot B, point B. So you don't know where it is going to come on this particular arc. Next, what is the point? OE is equal to 1.35 meters. That is 13.5 centimeters. Now you need to plot. So OE. So this is the point OE. So OE is nothing but on the same axis. So you're going to draw a red color dotted line with your scale. So now you're going to mark E point. Next is BE is 400 mm. So with E as center, so 400 mm means 4 centimeters. Now with 4 centimeters, cut this particular arc. So you are going to get point B. Ardhamaindi kada nana?
Yes, sir.
Yes. Next, you are going to extend this particular link. BE ఏదైతే ఉందో ఆ లింక్ ని you are going to extend it. Then you are going to mark BC is equal to 600 mm. So that means his, now if you observe here carefully, BC he is telling, now that means BC is a single link. Okay, so B and C is a single link. So what is the length of this particular link? Length 600 mm. So but in between they drilled a hole. So example, suppose this is the link. Okay, so this is the point B and this is the point C. సో ఈ లింక్ మధ్యలో ఒక హోల్ వేసారు అనమాట. ఈ హోల్ వేసి దీనికి తగిలిచ్చారు ఇంకో లింక్ కి. అర్థమైంది కదమ్మా?
Yes, sir.
Now with respect to this particular point, now BC is going to swing. Okay, I hope you got it. Now, so BC అయిపోయింది. What is the last? CD. CD is equal to how much? 500 mm. So with respect to C, you are going to draw an arc again. What? How much length? 500 mm. So I forgot to write here. So from this particular axis to D point, they have given 100 mm. So in the configuration diagram, you are going to take 1 centimeter. So this is how you are going to construct this particular configuration diagram. I hope you got it. Yes or no?
Yes, got it.
Yes, got it. Thank you. Now you need to find out what is the question he is asking. You need to find out velocity of B, velocity of C, velocity of D. Similarly, the angular velocities of AB, BC and CD. Okay, so input link aim Richard rotation, that is OA, is rotating at 120 rpm clockwise. That means n of OA is given. So how much he gave? 120. So how I can find out angular velocity of OA? Do you know the formula? Do you know the formula, ma?
2 pi n by 60.
Very good. 2 pi n by 60.
60.
So which is equal to 2 into pi into 120 divided by 60. Now 61, 62. So it is 4 pi radians per second. So tell me the value. What is the 4 pi value? What is 4 pi value, ma?
No, sir.
Use your calculators, Nana. Pi is 3.14. 4 into 3.14. Shall I use my calculator? I need to find where it is. Don't you? Are you not carrying calculators with you right now?
No, sir. I am at outside, sir. At my relative's home.
Oh. What about Vasu? Vasu, are you carrying? Okay, I have my calculators. Vasutej, are you there? Hello? Is he there, Vasutej?
Yes,
Oh,
sir. He is presenting, sir, but he's not talking.
Okay, maybe. I don't know. Think he moved or. Hello, Vasutej, you there? Okay. Okay, ma. So here it is 12.566 radians per second. See, from next class onwards, Raghu, you need to
Sir.
carry calculators, ma, because we are going to deal with problems a lot. So
Yes,
if you
sir.
don't have calculators, then it becomes difficult for you to
Yes.
understand.
Okay.
So omega OA, I got 12.566 radians per second. I got these two. So in order to find the velocity of B means what? The point. So this is the point. First, we need to mark the instantaneous centers. So first, how many number of links are there? Vasu, answer. Total. So we'll mark it. So this is link 1. So first mark all the fixed links. E point here is also a fixed link, and here also a fixed link is there. Next is OA is link number 2, and AB is link number 3, and BC is link number 4. E is the point, okay, where it got hinged. This link got hinged. Okay. C is not different link, same link. So this is fourth link, and CD is fifth link, and D is what? Point D is what? A slider.
A slider.
Slider, which is the sixth link. So how many links are there? Total? Six links are there. So which shape you can draw now? Which shape you can draw? Which shape you can draw by
hexagon,
using
sir.
Hexagon. I'm just drawing a hexagon. Okay. So I hope you got it. Clear?
Sir.
So this is hexagon I have drawn. So I'm just marking it 1, 2, 3, 4, 5, 6. See whether the please make sure that all these were joined. Okay, that means I12, I23, I234, I45, I56, and 16 needs to get joined. So we'll see now. What is this? O point is also called as I. O point is also called as link 1 and 2 were fixed, right?
Yes, sir. I12.
This is I12. What is this point? I. Second and third link. I23. What about B point? Third and fourth link were connected. This is?
Yes, sir. I34.
Now what about this particular point, E point? Link 1 is connected to link 4. Yes or no? This is I14. అర్థమైందా అర్థం కాలేదా?
Yes, sir. Yes, sir.
Here also a turning pair is there, right?
Yes, sir.
Yeah. What is about C point? I? Which links were connected at
I45.
I45. Very good. What about this? At this particular point, I? Particular point, I56. Fifth link is connected to the sixth link by using this particular turning pair. Okay.
Yes,
and
sir.
the sixth link is connected to first link by using which type of pair? Sixth and 1. 1 is the fixed link. With respect to fixed link, what this sixth link is going to do?
Sliding, sir.
Yeah, it's a sliding pair. Yes or no?
Yes,
so
sir.
Sliding pair is nothing but I16. Where it is going to lie? I16.
It is going
to in already sliding pair.
Surface.
Surface. I16 ఎక్కడ ఉంటుందమ్మా? Sliding pair instantaneous center. Where if you stand and see that this sliding motion may be a rotation.
Infinity, sir. Infinity.
Now where you went, ma? I'm calling you.
Sir, I'm talking, sir, but the voice is not working. So I'm exited and again rejoined.
Oh, you came back. Okay. So this is your I16 line. So at infinity. I hope you got it. Clear?
Yes, sir.
So you have marked these particular eye centers. Now we'll see if number of links are 6, how many eye centers you may have. So here n is equal to 6. So number of ICs are n into 6 n minus 1 by 2, which is equal to 6 into 6 minus 1 divided by 2. How many? 6 5 is 30. 30 divided by 2, how much? 15.
15.
Yeah. So 15 ICs. Now we'll mark those ICs. So I12, I13, I14, I15, and I16. Similarly, I23,
23.
24, 25, 26. Similarly, 34, 35, and 36. 45 and 46. 46. And this is I56. So we'll see how many have completed this particular figure. So I12 defined, yes or no? Here is I12. Next is I23. Next is I34, I45, and I56. Okay, so we'll mark those things. So I12, so I'll mark like this: I12 and I23, I34, 45, and 56 were marked. Yes or no?
Yes, sir.
Yes. So next I14 is also completed, and next
14.
I16 is also completed. Yes or no? I14 is E point, and I16 is this particular sliding. Got it? So this is I14, and next is I16. Yes, you have got it. Now you need to find out I13, I15, these many points you need to find out. Okay, but the beauty of this particular problem is, so in order to find out any of the angular velocities, you can go directly to those particular links. Okay, so first, what aim question అడిగాడు వాడు? So he is asking you to find the velocity of B. Now what is the velocity of point B? This is the point B. Yes or no? What is the I center here? I34. So here I am applying angular velocity theorem. So you are applying angular velocity theorem at I34. So I can say this particular point is on third link, and similarly it may be on fourth link. So velocity of 34 is equal to omega of 3 into I13 to I34. I can write down like this also. Omega 4 is equal to I14 I34. Antena? Yes or no?
Yes, sir.
Okay. Now you just tell me, can I proceed further? Do I know the angular velocity of link 3? Link 3 కి ఇచ్చాడు angular velocity question లో. అది కూడా కనుక్కోమన్నాడు కదా.
No sir, no sir.
He has
ఇవ్వలేదు sir.
omega of AB. What happened to this? He asked you to find out this particular omega of third link also AB. అవునా కనుక్కోమన్నాడా? Oh yes. And what about omega 4? Omega 4, did he mention any angular velocity of omega 4? No, right?
No
In
sir,
angular
no.
velocity ఇవ్వలేదు కదా. So you cannot find out. And you don't know I13. Have you defined I13? See, I13 is not defined yet. Yes or no?
Yes, sir.
Yes sir.
I34, yes, you know I34, but you don't know I13 here. I14 is defined again. So all these I centers were defined, but I13 is not defined. But here omega 3 is you don't know, and omega 4 you don't know. Velocity of this 3, 4 also you don't know. So these many unknowns are there. So how can I find out omega 3 and omega 4? So I can't go directly to this particular point 3, 4. So first what I'm going to do is I'm going to find out velocity of this particular point. What is this particular point? I23. So first I'll find out this particular velocity. Okay. Then I'll go to 3, 4. Got it? So see here omega OA is also omega 2. This is OA is nothing but link number 2. Okay, so omega 2 I got it. Now velocity of I23 I don't know. So you need to find out this velocity of I23. Okay, so what is velocity of I.23? So I'm using this particular point, instantaneous center, angular velocity theorem I'm applying on at this particular point. So it may be on second link and also it may be on link 3. So omega 2 into I. Ma, you have to be fast. Repeat it. Are you getting my point?
Yes, sir.
Yes. So 2, 3 and 1, 3. That's it. So do I know this particular point? I don't know about this velocity. Okay. So I need to find out. Otherwise, you can use this particular ratio omega 2, or I'll just take omega 3 is equal to, I'm finding out omega 3, which is equal to I 2, 3, I 1, 3 divided, sorry. So omega 2 into I 2, 3, I 1, 2 divided by I 2, 3, I 1, 3. అర్థమైందా అమ్మా?
ఎస్ సార్.
ఒమేగా 2 ఎంత వచ్చింది మనకి? 12.566 ఇంటూ వాట్ ఈస్ ద డిస్టెన్స్ బిట్వీన్ I23 అండ్ I12? ఇచ్చాడా వాడు అక్కడ? డిఫైన్ అయినాయా? ఫస్ట్ విల్ సీ ద డిఫైన్. I23, yes, it got defined. I12 is also defined. Okay, and where is I13? I13 define అయిందా?
No sir.
No sir.
What I have to do? I need to define I13. Yes or no?
Yes sir.
So to define I13, I'm just going to the figure. So I'm just joining this particular I13. Okay. So how I can go by I1? How I can go to I13? Sorry, we forgot to join a few more lines, ma. See, I12 we have joined, 2, 3 we have joined, 3, 4 we have joined, 4, 5, 5, 6. Okay. Similarly, I14, I16 కూడా వచ్చినాయి కదా మనకు పాయింట్స్. వచ్చినాయి రాలేదా?
Yes sir.
Yes sir. Yes
so
sir.
what you need to do is you need to join those points also. అర్థమైందా?
Yes sir, అర్థమైంది.
Yes sir.
Nana Vasitesh. Yeah. Now I need to find out I13. So how I can go to I13? I can go by 1, 2, 2, 3. If
Yes,
I join 1, 2, 2, 3,
Yes, sir.
I'll get 0.3. Yes or no? And also
Yes, sir.
similarly, I can join I14 and 4, 3. Yes or no?
Yes sir.
Yes sir.
So you need to have only 2 paths, ma. 2 path అంటే ఏంటిది? 2 points నుంచి వెళ్ళాలి. ఓకే, అంటే 1, 4, 4, 3 వెళ్తే నాకు 3 పాయింట్ రావాలి, లేదా 1, 5, 5, 3 ఇలా రాకూడదు. 1, 6, 6, 5, 5, 4, 4, 3 ఇట్లా జాయిన్ చేయలేం మనం. ఓకే, సో ఆ కెనడీస్ థీరం ప్రకారం ఏంటిది? 3 లింక్స్ మనం రిలేటివ్ మోషన్ లో ఉన్నాయని కన్సిడర్ చేసుకుంటే, ఈ 3 లింక్స్ యొక్క కామన్ ఐ సెంటర్స్ ఏవైతే ఉన్నాయో ఆ 3 ఐ సెంటర్స్ కూడా ఇట్ షుడ్ ఫార్మ్ ఏ స్ట్రైట్ లైన్. సో ఇక్కడ నాకు 3 ఐ సెంటర్స్ రావాలి. అర్థమైందా, అర్థం కాలేదా నాన్న? హలో.
No sir, no sir, once repeat it.
So what is Kennedy's theorem? I already explained na Kennedy's theorem. Kennedy's theorem lo ఏమన్నాడు? For the relative motion between the links in a mechanism, any 3 links, you can take any 3 links. Okay, the 3 instantaneous centers must lie in a straight line. Okay, so ఇప్పుడు నేను ఏం తీసుకుంటున్నాను? I13 కదా కావాల్సింది. I13, I14, 4, 3 పాయింట్, I12, 2, 3 పాయింట్. ఓకే, సో ఇప్పుడు నేను ఎన్ని పాయింట్స్ అయినాయి ఇక్కడ నాకు? I12 ఫస్ట్, I13 సారీ 1 minute, I1 ఇక్కడ చూడండి, I12, I23. సో 2, 3 చేస్తే నాకు ఏది వస్తుంది? I13 పాయింట్ డిఫైన్ అయింది. ఎస్ ఆర్ నో?
Yes sir.
Yes or no? That means if I join these 3 points, it forms a straight line. Okay.
Yes,
the
sir.
second
Yes, sir.
part, I can go by I14. If I join the points I14, I43, I'll get I13. Yes or no? That means
Yes sir.
if you join these 3 points also, it should form a straight line. అంతేగాని I16, I65, I4 ఏంటి 4, 5 జాయిన్ చేస్తే నాకు లైన్ వస్తుంది అనుకుంటే ఇన్ని పాయింట్స్ అని చెప్పలేదు కెనడీ. ఓకే, సో దాట్ ఈస్ ద డిసడ్వాంటేజ్. దట్ ఈస్ ద పాయింట్ యూ నీడ్ టు రిమెంబర్, నాట్ డిసడ్వాంటేజ్, సారీ. దట్ ఈస్ ద పాయింట్ యూ నీడ్ టు రిమెంబర్. సో ఓన్లీ బై 2 ways యూ కెన్ గో ఇట్. ఎస్ ఆర్ నో?
Yes sir. Oh, yes sir.
ఓకే, సో ఇప్పుడు నాకు I13 రావడానికి ఈ పాయింట్స్ ని జాయిన్ చేస్తే చాలు. సో వేర్ ఇస్ ద పాయింట్స్ I12 అండ్ I23? సో హియర్ ఇస్ ద పాయింట్. I12 is the point O and I23 is the point A. So you have to join these 2 points and you need to extend it. So I hope you got it now. Clear?
Yes, sir.
Yes. So I'm just joining by using white color chalk. So I'm just joining these 2 points. So I have extended it. So are you getting? I'm just extended.
I1 to I23.
Yes, we have extended it. Okay, so I have extended. What are the next 2 points we need to consider?
I14 and I43.
I14 and 43. Now where is I14? So E point is nothing but I14. Yes or no? You can see here.
Yes, sir.
Next, where is I34? B point is nothing but your I34.
I34.
So you need to extend these particular points. So it's taking time, this particular scale. Yeah. So I'm taking the same white color, so I've extended it. Okay, so we have extended it. Now what is this point? These 2 lines got intersected at this particular point. What is this I center? I13. I hope you got it. Is
Yes,
it
sir.
easy? Easy to
Yes,
understand?
sir.
Yes or no? Yes.
Yes, sir.
So we got I13. Now you just go to the angular velocity theorem. So you got I13 point also it defined. So what is the distance I23, I12? What is the distance of these 2 points, I12 and I23? Input link hai kadamma, OA link. What is the distance of OA link?
200 mm.
200 mm. So while substituting, the velocity units are in meters per second. Okay, so use all meters only. Or else if you are using mm, then you are supposed to write mm per second. Shall we take in meters or in mm?
Meters.
Meters, sir. Meters.
Meters. So it's 200 mm. Then convert into meters. How many?
0.2, sir.
0.2 meters divided by. Now distance, what is I1, I23 and I13? So you need to take your scale. This is I23 point and this is I13 point. So you need to mark the distance from I23 to I13. అర్థమైందా నాన్న?
Yes, sir.
Yes, but remember one thing. What you did in the configuration diagram, 100 mm is equal to 1 centimeters. Suppose here you are getting say some 600 mm. So by measuring it in the scale, you got 600 mm. అర్థమైందా అర్థం కాలేదా?
అర్థమైంది.
Yes, sir.
అర్థమైంది కదా? That means sorry 600 mm కాదు 6 centimeters అనుకుందాం. Because here we did in centimeters na, we plotted scale here in centimeters. Suppose here you got 6 centimeters. What you're going to do is, otherwise I'll make it somewhat complicated so further you can understand clearly. So it is 6.4 centimeters. After measuring it, the distance between I23 and I13. So this is the distance you got 6.4 centimeters. What you're going to do is side కి వేసుకోండి నాన్న ఇలా 100 mm ఏంటిది నువ్వు స్కేల్ ఎంత తీసుకున్నావు 1 సెంటీమీటర్ తీసుకున్నావు. సో సెంటీమీటర్స్ కింద you just take 6.4 centimeters and you need to have this particular number you don't know, so you need to cross multiply these two. So what you're going to get 6.4 into 100 divided by 1 centimeter. So how many centimeters you are going to get? 640. Sorry, 640 mm. అర్థమైందా? అర్థమైందా? So please note down this how to do it. So you need to write down. See here I'm just making you to understand. I don't know whether it is 640 or some number. So here it is 640 means how many? 0.64 meters. Okay. So from this you can find out what omega 3. Yes or no?
Yes, sir.
Yes.
So omega 3 is in radians per second. So in this manner you can find out omega 3. Next you got omega 3. Can you find out velocity of this particular point v of I23? You can take this particular relation and you can find out a velocity of I23. సేమ్. అర్థమైందా అమ్మా?
Yes, sir.
Yes, sir.
అర్థమైంది సార్.
Okay, so shall I move to the next? How to find out this particular point, omega of AB? Omega
Yes,
of
sir.
AB is nothing but the third link. So I'm going to the angular velocity theorem. Now, do you know omega 3 value now? వచ్చిందా రాలేదా omega 3?
Yes, sir. వచ్చింది సార్.
Yes,
వచ్చింది సార్.
omega 3 నాకు వచ్చింది. I13 పాయింట్ వచ్చిందా రాలేదా?
Yes, sir. Defined.
వచ్చింది. ఓకే, I34 పాయింట్ ఆల్రెడీ ఉంది, I14 పాయింట్ కూడా ఆల్రెడీ ఉంది. నౌ కెన్ ఐ ఫైండ్ అవుట్, ఓకే, నౌ కెన్ ఐ ఫైండ్ అవుట్ omega 4?
Yes, sir.
sir.
Omega 4, yes or no?
Yes, sir.
See, again I'm writing omega 3 which is equal to omega of AB. అంతే కదా? నాకు ఇక్కడ ఆల్రెడీ omega of AB ఏ కదా నా వచ్చింది. Omega 3,
Yes, sir.
which is the third link, is nothing but AB. Third link is nothing but AB link, na? See, please answer.
Yes, sir. Yes.
Yes, sir. Yes, sir.
Okay, so AB omega 3 వచ్చింది నాకు. omega 3, yes, it is known. See, I don't know why it is going zooming out and zooming in. Okay. Yeah. So omega 3 and omega AB both are same. Yes, it is known. Now, I13 to I34, because I13 point is also known. And similarly, I14 to I34. This distance is also known. Yes or no? Where is I14 point? So in the figure you can see this is I14 point.
I14
From
E,
here
sir.
to here. So B
E
is
to
the distance.
B. Yes,
Yes.
sir.
So now, because here all the three knowns are there, now from this you can find out omega 4. Okay. Can you find out omega 4?
Yes,
Yes,
sir.
sir.
So you can find omega 4. So will you able to do it? If I give this question as an assignment and in the next class, are you able to answer me?
We will try, sir.
No, you have to do it. Don't try, because you know.
Yes, sir. If the values has been
Values have been
అంటే నియర్లీ రావచ్చు సార్.
నియర్లీ వస్తే నేను చెప్తాను ఆన్సర్స్ ఎలా చేయాలో. మీకు ప్రొసీజర్ కరెక్ట్ గా ఉండి మీరు చేయగలుగుతున్నారంటే ఐఎమ్ హ్యాపీ. మీకు అర్థమైంది కదా?
Yes, sir.
Yes. So shall I stop this particular problem here, or we'll find out another? So shall I explain you another, or shall I go to the next problem?
No, sir, we can do it now.
So shall I complete this one?
We'll complete this, sir.
అరే
అర్థం కాలేదు, సరిగ్గా చెప్పండి.
వచ్చింది కదా సార్, చేసుకోవచ్చు.
మీరు చేసుకుంటారు కదా?
ఎస్ సార్.
ఓకే సార్. ఓకే సార్.
ఒమేగా సిడి అంటే దీని దగ్గర అప్లై చేసేయండి. ఒమేగా లైక్ I45 ఇలా అప్లై చేయండి. సో ఇట్ మే బి ఆన్ ఫోర్త్ లింక్ అండ్ ఇట్ మే బి ఆన్ ఫిఫ్త్ లింక్. సో ఫిక్స్డ్ రెఫరెన్స్ అయితే ఉండాలమ్మా. ఫిక్స్డ్ రెఫరెన్స్ తీసుకోవాలి. ఫస్ట్ లింక్ అనేది ఒకటి ఉండాలి. ఓకేనా? హెన్రీస్ థీరంలో 3 లింక్స్ లో ఒక లింక్ మాత్రం ఫిక్స్డ్ ఎప్పటికీను. Shall I move to the next problem?
Okay, sir.
Sir.
Okay. And also you can apply Kennedy's theorem here also. Okay. So if you apply I23, so I13 and I12, if I join these 2 points, it should be a straight line. So if I join here I12, I23 and I13, I12, I23 and I13, ఈ పాయింట్స్ ని జాయిన్ చేస్తే నాకు స్ట్రైట్ లైన్ వస్తుంది. మీరు మిగతావి కూడా అలా చేసి ట్రై చేయొచ్చు. And I'll take a snap, and after the class I'll just post to you, and I hope you are able to solve this particular problem and give me solutions.
Okay, sir.
Yes, sir.
Okay, sir. Yes, sir.
Okay. I hope you are going to do it, and we'll discuss a few more. I'll discuss a problem, but before that, you need to understand two particular concepts. That is mechanical advantage and toggle positions. I hope, have you heard of mechanical advantage?
No, sir.
So mechanical advantage. So this is a small definition you need to understand. So people will ask you this particular question for 1 mark. So mechanical advantage of a mechanism. So it is the ratio of force output per force input. So basically output to input is nothing but a mechanical advantage. I'll tell you uh, in brief now. So I'll just draw a mechanism. I'll just draw a 4-bar mechanism. This link is fixed. The link 1, 2, 3, and 4. 4 links were there, and this is I center I24 because we have marked these points. That's why. And these points is I13. And what is the angular velocity theorem? Omega 2. Example, if I take I24, so this is what we got. Angular velocity theorem. Okay. So mechanical advantage is nothing but so it is denoted with MA. It is the ratio of force output by force input, or you can take torque output divided by torque input. This is your mechanical advantage. And if you substitute this particular problem, okay, what is the relation between torque and omega? Anybody? So power is equal to what, ma? P into omega. So power, output power is equal to what? Torque output into omega output. Okay. Hello?
Yes,
Okay,
sir.
sir.
Okay, similarly, power input is equal to torque input into omega input. So from this also you can find out the relation. So what is the input power, output power divided by input power, which is nothing but efficiency of the
Efficiency.
very good, efficiency of the mechanism. So further I can write, so power output is torque output into omega output divided by torque input into omega input. Simply, you can also write like force output into omega output, one and the same, because here the ratio of both are same. Okay, so this is about the mechanical advantage. I hope you got it. So you need to
Yes,
remember
sir.
they may ask you for 1 mark question or 2 marks question, and I'll explain you one such particular problem as gate 2 marks question they have given again. So this is the problem 2, today's problem 2. So this is the question they have given. So this is link 1, and to this particular link 1, link 2 is connected by using a turning pair, and to this link a third link is given, and he is showing you a single slider crank mechanism, but this is the position of that particular mechanism. Okay, so what is this? Is link 1 again, this is link 1, and slider is link 4. Okay, so it is a single slider mechanism. So he's asking you to find out mechanical advantage at this particular position. Okay, so what is mechanical advantage? Here, what is
Force
input
input.
and what is output,
Force.
ma? To which link in single slider crank mechanism? To which link you are going to give input?
1, 2, sir.
1, 2. So I hope you remember this particular single slider crank mechanism. So this is your single slider crank mechanism. So this is fixed link. Fixed link ki input ella istam. Move avvadu kada. So to the second link you are going to give
2.
input. Advainda? So this is your
Yes.
input.
Second link is rotating.
And fourth link is your output.
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 Okay. So here mechanical advantage is nothing but what? Please tell me, ma. What is your mechanical advantage? For torque output
Hello?
Output, this thing also you can write down. Efficient. If you consider efficiency of a mechanism, so you can write down in this manner. How you can write down mechanical advantage is equal to, how you can write down efficiency of mechanism into, what is this? Please, please answer. Hello, omega of input.
Oh,
Can I find out
omega of
the
input.
omega of input divided by omega of output? This torque output by torque input is nothing but mechanical advantage, na?
Yes,
So I
sir.
can write down like this. So from your side, it should be fast, ma. ఇలా రాయచ్చా నేను అవుట్పుట్?
Yes, sir.
Yes, sir.
Right,
Right,
sir.
sir.
రైట్. సో do I know what is omega input?
Omega input. Yes, sir.
వాడు క్వశ్చన్ లో ఇచ్చాడా?
ఇవ్వలేదు సార్.
క్వశ్చన్ అసలు డేటా ఏమైనా ఇచ్చాడా?
ఇవ్వలేదు సార్.
ఓకే, నా ఇప్పుడు నాకు చెప్పండి, ఒమేగా అవుట్పుట్ ఎక్కడ తీసుకోవాలి నేను? ఫోర్త్ లింకే కదా?
Yes, sir. Slider.
స్లైడర్ ఏమన్నా యాంగులర్ వెలాసిటీ, స్లైడర్ లీనియర్ వెలాసిటీయా? స్లైడర్ మూవ్ అయ్యేది
లీనియర్ సార్.
లీనియర్ అంటే యాంగులర్ వెలాసిటీ ఏంటి స్లైడర్ ది? Angular velocity. Is there any angular velocity there?
No, sir. Zero, sir.
That's it. What is the mechanical advantage at this particular point now? Anything by
Zero,
zero
sir.
is what?
Zero,
Anything
sir.
by zero. Anything by zero.
Infinity.
Sir, infinity,
Infinite.
sir. Sorry, sir, infinity.
That's it. So mechanical advantage of this particular mechanism in this particular motion is infinite. Now you have observed this particular point infinite. That means nth advantage, and that means your output by input. జనరల్గా ఏంటి అవుట్పుట్ బై ఇన్పుట్ ఏంటి, తక్కువ ఉంటుందా ఎక్కువ ఉంటుందా? అవుట్పుట్ బై ఇన్పుట్ తక్కువ ఉంటుందా? అవుట్పుట్ బై ఇన్పుట్ ఆబ్వియస్లీ. అరే ఇఫ్ యు ఆర్ ఈటింగ్ సంథింగ్, ఓకే, సో దిస్ పర్టికులర్ ఇన్పుట్ ఏదైతే ఉందో నువ్వు తీసుకుంటున్నావు, అది ఎనర్జీ కింద ఫామ్ అవ్వాలంటే ఒక వేస్ట్ కూడా క్రియేట్ చేస్తుంది కదా?
Yes, sir.
Yes, sir.
అదే అర్థమైందా అర్థం కాలేదా? ఇంకా
అర్థమైంది
కదా, అంటే స్ప్లిట్ అవుతుంది. సో అవుట్పుట్ నీకు ఏదైతే వస్తుందో
ఇన్పుట్ కన్నా తక్కువ ఉంటుంది.
ఇన్పుట్ కన్నా తక్కువ ఉంటుందా లేదా? ఇప్పుడు నా అవుట్పుట్ బై ఇన్పుట్ తగ్గుతుందా పెరుగుతుందా?
తగ్గుతుంది సార్, తగ్గుతుంది.
కానీ ఇఫ్ యు అబ్జర్వ్ హియర్, మెకానికల్ అడ్వాంటేజ్ ఎట్ పర్టికులర్ పొజిషన్స్ ఇన్ఫైనైట్ ఉంది, అంటే యూ కాంట్ మెజర్, అంత ఎక్కువ ఉంటుంది అనమాట. ఓకే, సో దీస్ పర్టికులర్ పాయింట్ వేర్ మెకానికల్ అడ్వాంటేజ్ ఇస్ ఇన్ఫైనైట్, then we are going to call these positions as toggle positions. Okay, got it or not? So toggle position ఎప్పుడు అంటాం? ఎప్పుడైతే మెకానికల్ అడ్వాంటేజ్ ఇన్ఫైనైట్ ఉంటుందో ఆ పర్టికులర్ పాయింట్స్ ని మనం 1 minute ఆ పొజిషన్ మనం ఆ పాయింట్స్ కానీ ఆ పొజిషన్ ని కానీ మనం మెకానికల్ టాగల్ పొజిషన్ అని వాడుకుంటాం అన్నమాట. ఓకే, why it is zero, అక్కడ జీరో ఎందుకు వచ్చింది అవుట్పుట్? బికాస్ reciprocation. Okay, straight line has infinite radius. Got it or not?
Yes, sir.
Okay, so I hope you got this particular mechanical advantage and toggle position also. We'll solve a small problem, and this particular problem here we are going to use slotted lever crank mechanism, and you need to understand here you have like 2 points. ikkada oka 2 points untundi. People are going to get confused. So gate problem anamata idi. So I'll just give me a minute. So meanwhile you can draw the figure in your books also. So
okay,
I'll take some few minutes, let's say 2 to 3. This is 4. Else 4A. Okay. So this is the figure, ma, and I hope you got it.
Yes, sir.
So what question లో ఏమి ఇచ్చాడంటే this is the difference he gave in the question. So you can see here the point B comma C and ఇచ్చాడు వాడు. Okay, you may get confused. So he to construct the figure he gave like this the data. OA is equal to 700 mm. So you can for drawing configuration diagram again you can use the scale. So OA is equal to 700, OB is equal to 300 mm, and AD is equal to 1400 mm, and DR is your R. dr is equal to 500 mm. So he's telling that if crank OB, so this is his statement, crank OB rotates at 40 rpm anti-clockwise direction, ACW anti-clockwise direction, then find the velocity of and find the velocity of ram. So he's asking you to find the velocity of ram because ram is nothing but a slider, so it has only linear velocity. So this is what he is asking you to find. So now just tell me this particular point B is on crank or is on this particular slotted lever. So this is your slotted bar, right?
Yes, sir.
Slotted bar, and this one is the fixed link or coupler, and this is your crank, and this is your slider. Now, so in the question he is stating that crank OB. So the meaning is nothing but, so OB is nothing but point is on crank. So this is one end of the crank point is point O. The other end we are going to call it as B. So this particular B point is on the slider. Okay, because on the B your slider is connected. So this is your slider. So slider is connected at particular point B. Now what is the point C? Sir, now I'm getting a doubt why he gave C point. So at this particular position, okay, at this particular position, now the C point is on the slotted bar. So at this particular position, B and C points are intersecting. Have you got it
Yes,
now?
sir. Yes, sir. Yes, sir.
Now C is a point on slotted bar. So don't get confused with point B and point C. Now you just tell me one thing. So C point, because it is on the slider, okay, so how many velocities will be there, and B point which is on the slider, how many velocities this particular point B is going to have. That is the major difference you need to understand. Okay, now I am going to discuss these things now in detail. Got it? So here I'll just draw a simple figure so that you people can easily understand. I'm drawing a small figure here. This is A and this is O. So with respect to O as center, your slider is, sorry, your crank is rotating. This is your crank OB. This is your slotted bar. So B is going to rotate. So B point is rotating with respect to what? Point O. Okay. So if I say B point velocity when it is rotating, because here the slider is there, so how the velocity direction will be there? How the velocity direction will be there? Ma, please
Sir,
let
sir,
చెప్పనా
yes, sir. ఒకసారి మళ్ళీ చెప్పరా సార్ అది?
ఇప్పుడు ఈ స్లైడర్ ఒక వెలాసిటీ నీకు కావాలి అనుకుంటే విత్ రెస్పెక్ట్ ఈ స్లైడర్ దేని కనెక్ట్ అయింది చెప్పండి ఒకసారి. ఈ స్లైడర్ అనేది ఏ కనెక్ట్ అయింది? ఓకే. ఈ స్లైడర్ అనేది క్రాంక్ బి పాయింట్ అనేది బి పాయింట్ అనేది ఏంటిది? స్లైడర్ పైన అంటున్నాను. ఓకే. అంటే ఇది లింక్ 1 అనేది ఫిక్స్డ్ అనుకుంటే క్రాంక్ అనేది లింక్ 2, స్లైడర్ అనేది లింక్ 3, స్లాటెడ్ బార్ అనేది లింక్ 4. అవునా? ఇప్పుడు స్లైడర్ అంటే థర్డ్ లింక్ కి సెకండ్ లింక్ కి ఏ పాయింట్ దగ్గర కనెక్ట్ అయింది? బి పాయింట్ దగ్గరే కదా? అవునా? బి పాయింట్. ఎస్ ఆర్ నో? ఇట్స్ ఎ టర్నింగ్ పేర్. సో ఇప్పుడు క్రాంక్ ఇలా రొటేట్ అవుతుంది అనుకుందాం, అంటే యాంటీ క్లాక్ వైజ్ రొటేట్ అవుతుంది అనుకుందాం. ఇప్పుడు క్రాంక్ ఏం చేస్తుంది? స్లైడర్ ని కూడా గుంజుతుంది కదా. ఓకే. బికాజ్ ఇలా రొటేట్ అవ్వడానికి ట్రై చేస్తుంది స్లైడర్. అవునా? స్లైడర్ విత్ రెస్పెక్ట్ టు ఫోర్త్ లింక్ ఎలా కనెక్ట్ అయింది? ఫోర్త్ లింక్ తో స్లాటెడ్ లో ఉంది. అవునా? అంటే ఏంటిది? స్లాటెడ్ బార్ లో అది స్లైడ్ అవుతూ ఉంటది. ఎస్ ఆర్ నో? అంటే విత్ రెస్పెక్ట్ టు ద స్లాటెడ్ బార్, ఇది స్లాటెడ్ బార్ అనుకుందాం, సో నా స్లైడర్ ఏదైతే ఉందో అది దీంట్లో ఇట్ హ్యాస్ ఓన్లీ వన్ మోషన్, ఇట్ కెన్ ఓన్లీ స్లైడ్ రెసిప్రొకేట్. అంటే ఏంటిది? ఇది రొటేట్ అవుతుంటే ఇది కిందకి వెళ్ళొచ్చు, ఇది కిందకి వెళ్ళొచ్చు లేదా పైకన్నా వెళ్ళొచ్చు. అంటే ఇలా స్లైడ్ అవుతూ ఉంటుంది. ఇప్పుడు నాకు చెప్పండి, ఏ టైప్ ఆఫ్ వెలాసిటీ ఉంటుంది ఇక్కడ? లీనియర్ వెలాసిటీ సార్. I hope you got it now. Okay. So first ఏంటంటే రొటేషన్. ఓకే. విత్ రెస్పెక్ట్ టు ద క్రాంక్ ని తీసుకుంటే రొటేషన్ కాంపోనెంట్ you are going to get. Yes or no?
Yes sir.
So velocity of slider in rotation component. సో సెకండ్ నేను తీసుకుంటే అంటే విత్ రెస్పెక్ట్ టు ద స్లైడర్ నేను తీసుకుంటే ఏమవుతుంది? అది స్లైడింగ్ వెలాసిటీయే కదా.
స్లైడింగ్
వెలాసిటీ ఆఫ్ స్లైడర్ సెకండ్ అది. ఓకే. సో స్లైడింగ్ వెలాసిటీ ఎలా ఉంటుంది? వాట్ ఈస్ ద డైరెక్షన్? దిస్ ఈస్ ద డైరెక్షన్ ఆఫ్ ద స్లైడింగ్ వెలాసిటీ. ఎస్ ఆర్ నో? Rotation component, how the rotation component will be there? It is exactly perpendicular to the link. If OB है kada link, so OB link. So here it will be
perpendicular to the OB.
Yeah, perpendicular to OB. Very good. So here 1 minute. Yeah, this is your ఇది 1 minute ma. So this is your velocity of point B. Okay.
Okay sir.
So basically ఈ స్లైడర్ కి ఒక పర్పెండిక్యులర్ గా if you draw it, slotted bar, because you need to find out C velocity also, right? C point.
Yes sir.
With respect to slider, if I am taking, that means here my slotted bar is rotating in anti-clockwise direction. Yes or no?
Yes sir.
అంటే అప్పుడు నా C point velocity ఏంటి? రొటేషన్ కాంపోనెంట్ ఉంటుంది కదా. Yes or no?
Yes sir. This
is the component. So its direction is like this. Okay. And ఇప్పుడు ఆ C point అంటే ఈ స్లైడర్ అనేది రెసిప్రొకేట్ అవుతూ ఉంటుంది. అవునా? So that means its sliding velocity will be in this particular direction. Got it or not?
Yes sir. Yes sir.
Okay. So now these are the 2 points you need to remember. So this point అంటే point C, మనం C తీసుకుంటున్నాం, B కాదు. So this point C point has how many components? 2 components you have. అర్థమైందా? అర్థం కాలేదమ్మా?
అర్థమైంది సార్. అర్థమైంది.
వెలాసిటీ B, VB కి ఎన్ని కాంపోనెంట్స్ ఉంటుంది? ఓన్లీ సింగిల్ కాంపోనెంట్. B is the point of the crank. ఓకే. స్లైడర్ కి కనెక్ట్ అయిన పాయింట్. ఇది రొటేట్ అవుతుంటే ఆబ్వియస్లీ ఇట్ ఈస్ పర్పెండిక్యులర్ టు వెలాసిటీ వెక్టర్ ఈస్ ఆల్వేస్ పర్పెండిక్యులర్ టు ద లింక్. Yes or no? But C
Yes, sir.
point, because it is there on the slotted bar, ఈ point కి ఏంటి, with respect to the slider, it is
Slider
rotated.
and with the
Also, it has a what reciprocation. So ఈ two velocities ఉన్నాయి కాబట్టి ఈ resultant of two velocities gives you the velocity of point C.
another vector.
Okay, got it or
Yes,
not?
sir.
అర్థమైంది,
Yes,
అర్థం
sir.
కాలేదు. Now how to plot this particular relative velocity method, and I'm going to tell in detail because I am taking this particular example. So I will finish off by how to plot this particular figure. So first you need to have input. So ఇక్కడ ఇన్పుట్ ఏంటిది, OB కదా, crank rotation.
OB, sir. Yes, sir.
Crank OB rotates at 40 rpm అని ఇచ్చాడు. So here n of OB is equal to how much? 40.
OB equal to 300 mm, sir.
OB is equal to 40
okay, sir.
rpm, right?
Yes, sir. Yes, sir. Yes, sir.
Omega of OB is equal to 2 pi n
2 pi n
divided
by
by 60. So
Yes, sir.
here 2 pi n is how much? 40 divided by 60. So I don't think you have
calculating, sir. Calculating.
calculating. Oh, great. Thank you. ఎంత వచ్చింది?
Yes.
I don't think this sum is going to complete today. I have
4.18, sir.
4.18 units, radians per
Radians per second.
second. So I got input. So from this you need to find out velocity of B point. How you are going to find out velocity of B? R omega, right? What is R
VB
here?
equal to R omega.
OB
R
into
OB, sir.
omega of
OB.
What is the distance of OB? I have given here, right?
OB
equal to
300 mm, sir.
So convert into meters, that is 0.3
0.3 into
4.18.
Yes, sir.
How
Yes,
much?
sir. Calculating, sir.
Yeah.
Oh shit. Wait, sir.
4.18, na?
Yes, sir. Yes, sir.
It's 1.25.
1.254
Yeah, something you are going to get. What are the units?
units meter per second.
Per second. Okay, got it. Here omega
Yes,
is
sir.
radians per second. OB is meters. So your final units become meter per second. You got now input. See here, till now we have discussed about what instantaneous center method. So this problem I have given, and we are finding using relative velocity method. Okay, na? So the
Okay,
same
sir.
problem we'll do for acceleration analysis also. Don't get confused. So this is
Okay,
by
sir.
using relative velocity method I'm using. So here instantaneous centers will not come into picture. So you required input velocity you required, and that input velocity you got, that is VB is equal to 1.25
1.25.
meters per second. Okay, got
Yes,
it
sir.
or not? So
Yes, sir.
now next you need to find out how the procedure, how to draw this particular procedure. So I'll just explain you. Now point C అయితే అర్థమైంది కదమ్మా, కోఇన్సిడెంట్
Yes, sir.
పాయింట్ ఆఫ్ స్లైడర్ B but on slotted bar మీద ఉంటుంది. ఓకేనా?
Yes,
C
Yes,
has
sir.
so we'll do it. So okay, so 3 columns, draw 3 columns. So this is a method, or shall I continue in the next class? మీకు నెక్స్ట్ ఇంకోటి ఏదైనా ఉందా సబ్జెక్ట్
Got
ఉన్నట్టు?
it, sir. Yes, sir.
అది స్టార్ట్ అయిపోయి ఉంటుందేమో. I don't think like ఈ సమ్ కంప్లీట్ చేయడానికి it will take some time, maybe half an hour to again. That's why.
నెక్స్ట్ క్లాస్ డిస్కస్ చేద్దాం సార్.
సరే అయితే ఇక్కడతో నేను ఆపేస్తున్నా. హలో
Okay,
మేడం,
sir.
I think madam she's there.
no sir.
Okay, I'll take 1 minute, ma. I'm just noting down Vasutej mail ID. So, in the chat box it was written the same mail ID, no, ma?
Yes, sir. Yes.
Okay, so I'll just note down.
Yes, sir. Yes.
Okay, so I have noted down. So I'm going to send you. I think
Okay, sir.
she texted. Okay, thank you then. We'll meet again in the next week. So I hope,
Okay,
madam.
sir. Thank you, sir.
Uh, hello, madam.
ఓకే సార్, ఓకే సార్, అయిపోయిందా క్లాస్?
Yeah, yeah.
ఓకే, నెక్స్ట్ ఈఎం కూడా వెయిటింగ్ అన్నారు. రైట్,
Thank you, ma'am.
థ్యాంక్ యూ.
Sorry, delay in.
నో ప్రాబ్లం సార్, థ్యాంక్ యూ.